All right, so I've already solved this one, but it was an interesting road to get here. 3011. Find if an array can be sorted. You are given a zero-indexed array of positive integers nums. In one operation, you can swap any two adjacent elements if they have the same number of set bits. Set bits being the number of ones in a binary string. You are allowed to do this operation any number of times, including 0. Return true if you can sort the array, otherwise return false. So my first thought was that I would basically say, so if we need to get this 2, we have this 2 and we need to get that to the first position. Well, that means that the number in the first position has to have the same number, well, the same number of set bits as the one in the third position. And what this translates to is that for all the numbers, if you convert them to their number of set bits, that if you sort it and then convert it, and if you leave it unsorted and then convert it, those two arrays should be the same, because you have one where it's like the goal, the result. So the set goal location of all the numbers should equal it's hard to express. The number of set bits for a number's goal location should be equal to its original location. So, for example, we have this 2 and we need to get to 8, so that means to the spot of 8. So that means that 8 has to have the same number of set bits as 2, which it does because they only have one set bit. Because 8 is 1 0 is a 1 0 0 0 and 2 is 1 0. Now, the problem with that was that I didn't consider it actually worked for 992 out of what was it? Worked for 992 out of 999 test cases. And the reason why was because there's this case right here, and that's because I skipped one word, being adjacent. So we have 75, 34, 30. 75 and 30 had the same number of set bits, but 34 doesn't. But you had to swap them adjacent. So you had to swap the 30 with the 34, which you can't do, meaning that it can't end up being sorted. The thing that I had would work if you could just sort any two pairs, if you could swap any two pairs, and it would actually be a pretty good solution. But that's not the case. I tried to see if you could do a quick fix by maybe doing one little pass through and seeing if, you going through the array for every pair of numbers, if they were out of order, could they be swapped? This right here. So if nums I is greater than its next number, is the number of bits the same for those two numbers? Meaning, okay, well, if it's out of order, can you swap them? And then you just return, okay, is the goal set bits locations equal to the original? That did not work, but here's what's fascinating is that it worked for 998 test cases. I've never seen that before. The reason why is because this would, it would work for a test case like this, but if you have a little buffer, then that one pass-through doesn't handle like all of the neighbors. It only handles pairs that are directly next to each other that fit these conditions, but you could have like a buffer between them. It's hard to describe, and I'm getting too wordy here. But the solution that I ended up using was by just recognizing, okay, so it's sorting, and we're trying to get adjacent numbers. So that's just a bubble sort. To do a bubble sort, you swap adjacent numbers. So I could just basically try to do a bubble sort and then see if at any point, when I'm trying to, am I stopped by the set bit condition? So we have this right here. I actually just copied and pasted this bubble sort. I made this little map function to convert an array to its number of set bits for every number. And then I just do a bubble sort and I swap the numbers in the set bits. And if there's ever a time where two numbers that I would swap can't be swapped because their set bits aren't equal, I return false. And then if I make it through, then that means that I successfully sorted it. So that's the solution, or that's a solution. It's not the fastest solution, but as you can see, I'm kind of wonky at the moment. So Yeah, awesome.